it's easy to forget just how vulnerable our planet really is. We live on a delicate blue marble, spinning peacefully through the darkness, bathed in sunlight and wrapped in a thin film of air. The oceans shimmer, the winds blow, and the moon floats gently above, seemingly timeless and eternal. But if you take a moment to look closer, to really look, you'll see something unsettling. That moon, it's not pristine, it's wounded. Its surface is a battlefield, scarred and pitted by ancient trauma. Giant craters gape like old war wounds, silent evidence of a time when the heavens turned hostile and the skies opened fire. This wasn't a gradual siege. It wasn't some slow, distant erosion of time. It was a storm, a cosmic onslaught. Scientists call it the Late Heavy Bombardment, a terrifying and mysterious chapter of our solar system's past, when a barrage of asteroids rained down on the moon and likely Earth as well. If this really happened, it wasn't just some incidental violence of nature. It may have been the very thing that allowed life to begin. But why did it happen? And how did the Earth, fragile and forming, survive what the moon clearly could not? To find answers, we need to rewind time, not just a few centuries or millennia, but nearly 4 billion years. Back to an age of fire and chaos. To a time when the planets were still infants and the sun itself had only recently ignited. When the Apollo astronauts returned from the moon in the late 1960s and early 70s, they didn't just bring back photographs and stories of bouncing in low gravity. They brought back pieces of the moon itself, 382 kilograms of it. Ancient rocks, dust, and minerals, each carrying secrets from the earliest moments of our solar system. And among those secrets was something unexpected. Nearly every sample that had been melted and reshaped by impact, the kind of rock that forms when a meteorite slams into a surface, seemed to date back to the same narrow window of time, around 4.1 to 3.8 billion years ago. Not randomly spread across billions of years, not scattered evenly throughout the moon's long history, but clustered, tight, focused. As if the moon had endured a sudden, furious onslaught, millions of violent impacts crammed into a blink of cosmic time. That finding was unsettling. It suggested that something enormous, something terrifying, had once gone wrong in our solar system. That instead of the violence of planetary formation slowly winding down as the solar system matured, something had triggered a new wave of destruction. Something had woken up and thrown rocks the size of cities across the solar system. And for a long time, nobody knew what that something was. The theory of the late heavy bombardment remains controversial. Not every scientist agrees it happened. Some argue the evidence is skewed, distorted by limited samples from just a few areas on the moon. Others believe it could be real. But the cause? That was the true mystery. Why, hundreds of millions of years after the planets had formed and things had begun to quiet down, would the inner solar system suddenly be torn apart again? To understand this mystery, we must go back even further, back to the solar system's beginning. Our story starts in darkness, in a cold, spinning cloud of dust and gas. For billions of years, it had drifted between stars. But then, something changed. Perhaps a nearby supernova exploded, sending shockwaves through the cloud. Gravity began to pull the dust inward, spiraling it into a glowing disk, heating it, crushing it, transforming it. At the heart of this swirling chaos, a new star was born, our sun. The material that didn't fall into the sun began clumping together. First, tiny grains of dust bonded into pebbles. Then, pebbles into rocks. Rocks into boulders. And eventually, boulders into planets. These early building blocks, called planetesimals, smashed together with unimaginable violence. Worlds were born not with a whisper, but with a scream. Within about 100 million years, the terrestrial planets had taken shape. Mercury, Venus, Earth, and Mars. Their surfaces bubbled with molten lava. Their skies were filled with choking clouds of methane and ammonia. And one of these cataclysmic collisions flung a massive chunk of molten Earth into space, where it eventually coalesced into our moon. That impact, too, was violent beyond imagination, so powerful that it almost destroyed the Earth itself. By this point, the inner solar system had started to settle. Most of the loose material had either been swept up by forming planets or flung into deep space. The worst, it seemed, was over. But then something happened. Something that shattered that fragile calm. Because hundreds of millions of years later, the moon suddenly found itself under siege. The evidence is right there on its face, visible every time you look up into the night sky. Crater after crater after crater, some hundreds of kilometers wide. Evidence of colossal impacts that must have shaken the moon to its core. And here's the most important question. If the moon took this kind of beating, how did Earth avoid it? The answer is, it didn't. Earth, too, was struck, again and again. But unlike the moon, Earth had something the moon never did. Movement. Tectonic plates, erosion, oceans, weather. Our surface churned and changed. It healed. It buried its scars. Today, almost nothing remains of those impacts but the consequences of them. Those may be all around us. So what caused this sudden storm of asteroids? What force hurled rocks toward the inner planets long after the solar system had supposedly settled down? The answer may lie with the most massive planet of them all, Jupiter, the king of planets. A world so immense it outweighs all the other planets combined. It has a magnetic field 10 times stronger than Earth's, and its gravity reaches out across hundreds of millions of kilometers. Jupiter has always been a cosmic disruptor. And in this case, it may have caused one of the greatest bombardments our planet has ever seen. You see, Jupiter didn't always sit where it does today. At the beginning, it was migrating, being pulled and pushed by the thick gases that still swirled around the young sun. As it moved inward, it swept through regions of the solar system that were packed with planetesimals, fragments of rock and ice left over from the solar system's formation. When Saturn formed shortly after, its gravity caught Jupiter's and yanked it back outward. The two giants settled into a complex gravitational dance, but not before they'd wreaked havoc. That dance, Jupiter rushing inward then pulling away, sent waves of chaos through the solar system. It disrupted everything. It shattered orbits. It threw rocks inward, toward the sun, toward Earth, toward the moon. This may have been the moment that triggered the late heavy bombardment. Jupiter, in its sweeping migration, had essentially opened the gates, and the rocks came tumbling through. The ancient solar system was a place of breathtaking violence. Picture a sky not filled with stars, but with fire. Asteroids, glowing red and orange from the heat of friction, falling like rain across the infant moon and Earth. One after another, relentless. The moon, lifeless and still, had no defense. It absorbed every blow. And Earth, still unstable, with a crust only just beginning to form, trembled under the weight of the impacts. But this devastation brought with it something extraordinary. It didn't just scar the moon, it delivered the ingredients for life. Because these weren't just any space rocks, they came from two distinct regions of the solar system, some from the inner belt, some from the outer reaches. And they weren't all made of the same stuff. Some, the S-type asteroids, were dry and rocky, composed of silicates and nickel iron. They came from the warmer inner solar system. But others, the C-type asteroids, were different. They were older, colder, and they carried something precious. Water. Water, in vast quantities, frozen inside these ancient messengers from the edge of the sun's dominion. And this right here may be the miracle of it all. Because these outer belt asteroids, flung inward by Jupiter's migration, didn't just bring ice. They also brought carbon, organic compounds, and the building blocks of life itself. Molecules like amino acids, hydrocarbons. The pieces of the puzzle that would, one day, assemble into something living. Had this storm arrived earlier, when Earth's surface was still molten, its atmosphere too thin and wild to hold anything in, that water would have boiled away, lost to space. But it didn't. It came at the perfect time. A time when Earth had just begun to stabilize. The crust, called the lithosphere, had cooled enough to form a solid surface. Beneath it, magma still flowed like blood. But above, there was a window. A chance. And into that window fell the seeds of everything. The Earth was still hellish, of course. The atmosphere was toxic. Methane, ammonia, sulfur compounds thickened the air. Lava burst from cracks in the crust. Steam hissed from boiling seas. Volcanoes erupted in the distance. But slowly, as more water arrived, the oceans began to take shape. Pockets of calm formed on the surface. The sky began to change. Imagine it, a dark world, steaming and violent, under constant bombardment, yet quietly transforming. The water began to cool the planet, to settle it, to prepare it. And in the chaos, something unexpected happened. Somewhere in the tide pools, in the cracks between volcanic rock, the first glimmers of life appeared. Simple, microscopic, ancient, but alive. Life. Not in spite of the bombardment. Because of it. Those asteroids may have carried more than just molecules. They carried momentum, energy, catalysts for change. And when they struck Earth, they didn't just leave craters. They cracked the shell of the planet and opened pathways for heat, chemicals, and water to mix in new ways. They stirred the cauldron, and out of that heat and violence, something stirred. Today, it's impossible to know exactly how it happened. The rocks from that time are long gone, subducted into Earth's mantle or erased by erosion. Our planet is too dynamic, too restless to preserve the scars. The oldest rocks on Earth date to just after the bombardment ended, around 3.8 billion years ago. But the fossils, the chemical traces of the earliest living cells, they appear almost immediately after that point. Life may have begun in the very wake of destruction. It's not just poetic, it's scientifically compelling. And the moon? That lonely guardian in the sky? It holds the evidence we can't find on Earth. Its surface is like a museum exhibit frozen in time. No weather, no wind, no rain to erase what happened. The dust is made of pulverized stone, untouched for billions of years. The craters remain, vast and circular, like scars carved into bone. They tell the story that Earth tried to bury. They preserve the memory of the storm. Every time we look up at the moon, we're seeing a graveyard of impacts, a reminder of the chaos we survived. There are craters on Earth too, of course. The famous Barringer crater in Arizona is one. But it's only 50,000 years old, practically yesterday in planetary time. The impacts from the late heavy bombardment? If they still exist on Earth, they're buried deep under continents or hidden beneath oceans. The story lies beyond our reach, and that's why those moon rocks from the Apollo missions are so important. Those 382 kilograms of gray dust and shattered stone are time capsules. We've studied them, scanned them, dated them, and they all tell the same tale. Something happened around 3.9 billion years ago. Something violent. Something widespread. The rock was melted, shattered, reshaped, and then cooled. And the pattern was consistent across every sample. That evidence is what gave birth to the theory of the late heavy bombardment. But as science advances, some are beginning to question the idea. Could those impacts have been spread out more slowly over time, instead of crammed into a single catastrophic window? Could the evidence be misleading, shaped by the limited locations where samples were collected? It's possible. That's the nature of science. Every answer raises new questions. Every discovery opens another door. And yet, the story holds. It explains so much. Why the moon is scarred. Why Earth's oceans exist. Why life may have emerged when it did. And even if the late heavy bombardment wasn't exactly as we imagine it, something big happened during that time. Something that changed the trajectory of our world forever. And the fingerprints of Jupiter are all over it. The massive planet didn't just form early. It didn't just shepherd the asteroid belt or fling comets around the solar system. It may have shaped the very foundation of Earth's history. Not by intent, of course, but by gravity, by presence, by sheer weight and motion. Jupiter's dance with Saturn, that brief and powerful interaction, may have been the domino that tipped the board. Without it, Earth might have remained dry, lifeless, a rock among rocks. But because of it, because of that moment, the pieces fell into place. Sometimes the most miraculous stories don't begin in peace. They begin in fire, in violence, in the roar of cosmic debris smashing into newborn worlds. What Jupiter may have unleashed 4 billion years ago was not just destruction but transformation. A cleansing storm, a reset. and perhaps a divine accident. And yet, our understanding of it all is still so fragile. We are detectives in a world that has hidden its evidence. The Earth has buried its past under mountains and oceans, under lava flows and tectonic drift. What happened during that ancient bombardment is not written in the pages of a book, but in fragments, clues scattered across the moon, embedded in ancient rock, encoded in the chemistry of meteorites. We're left piecing it together like archaeologists of time itself. And as we dig deeper, we keep returning to one central question. How did life emerge from the wreckage? We know now that the 5 fundamental building blocks of DNA and RNA, the molecules that make life possible, can form in space. We've discovered them in the hearts of ancient meteorites, preserved across time and distance. These molecules are delicate, yes, but they're not rare. They are part of the universe. Seeds, waiting for a garden. What we don't know is how many planets were given that gift, only to lose it. Because timing, we now understand, was everything. Had those molecules arrived too soon, Earth would have been too hot to hold them. Had they arrived too late, the window for chemistry to blossom might have closed. Life may not have had a second chance, but the timing was perfect, or lucky, or divine. The world was just cool enough to hold water, just stable enough to preserve an atmosphere. The seas had begun to form, and within them, in the darkness, something began to stir. Some spark, some chain of reactions. Perhaps lightning struck a mineral-rich tide pool. Perhaps vents deep in the ocean floor created warmth and pressure. Whatever the catalyst, life found a way. And as life began to write its first chapter, the bombardment came to an end. The surface of Earth slowly calmed. The atmosphere thickened. The oceans deepened. Plate tectonics began their eternal shuffle. And somewhere in all that change, single-celled organisms flourished. They were simple, barely alive by modern standards, but they were the beginning of everything. We can't trace them precisely. Their fossils are lost to time, but their legacy is in our blood, in our cells, in the DNA we carry. A lineage that stretches back, not just millions of years, but billions. Back to the end of the Hadean era. Back to the very chaos from which we were born. And the moon? Still watching, still circling. A silent witness to the entire story. It preserves what Earth has lost. The craters, the impact basins, the untouched dust. It is a time machine. That's why the Apollo missions were so vital. Those few short walks, those scoops of rock and soil, gave us glimpses of an era long buried. They allowed us to measure, to test, to wonder. But those samples came from just a handful of sites. A few areas on the moon's near side. There's so much we still don't know. That's why future missions, like NASA's Artemis program, carry such weight. Another moon landing, perhaps as soon as 2026, could open new frontiers. We may find new rocks, new data, new clarity. And maybe then the picture will sharpen. Maybe we'll see the full arc of the late heavy bombardment, not as a speculative theory, but as a chapter of history written in stone. Even now, not everyone agrees with the story. Some scientists think the impacts may have stretched out over a longer time, slowly tapering off from the initial formation of the planets. Others point to inconsistencies in the dating of craters. Maybe it wasn't a single violent storm, but a long twilight of falling debris. But whatever the details, the outcome remains. The water came, the life began. And Earth, against all odds, became something more than rock and gas and molten iron. It became home.